customer server responses, then product prices. So all those stuff we can get as a data, right? Those are examples. When it's come to the information is something slightly different. That is, information is kind of a analyzed result of the data, right? Then it has a context, then can be used to help them make the decisions. It is kind of has a meanings, right? An example, web traffic changes, then customer sentiment based survey results. So those are the sort of, we can consider those are as an example for the information. So I believe you got an understanding about the difference. This is kind of an raw thing, and this is kind of analyzed result, right? Okay. So let's go to the big data, right? So from the name itself, this is huge, right? So this is a huge data, right? So the big data is also data, but with the huge size, right? So as an example, just think that the data what we discussed so far is, if you get a hypothetical, this is this much of size, then we are talking about maybe 1,000 times or bigger than the data compared to the data what we discussed so far, right? Very huge data, right? I will explain little by little how huge this data, right? And the other thing, this is a term used to describe the collection of the data in a vast volume, right? This is a vast volume and continues to grow exponentially over the time. This is the other thing. When we discuss about this data, this will grow over the time in a exponential. It shows a exponential growth. The exponential growth is something you know that in your mathematics class. So usual growth is like the example. Let me clear all drawing. So usual growth, we say that it's a y equal mx, something like this, right? If we have this kind of a growth, we say the usual growth. But when it's come to huge, it has an exponential growth like this, right? It's as a curve in the gap is coming larger and larger over the time. So that's why we are telling this as an exponential growth, right? So because of this exponential growth, the data is growing very quickly, right? Then and also those data is a very complex data, right? The complex sense because of the size of the data when compared to the traditional data or the data what we discussed so far, it is kind of a complex. And other thing is that traditional data management tools are not able to store or either analyze this kind of a data, because those our legacy tools like maybe Excel, maybe CSV, maybe our old tools what we are using to analyze this kind of data, those legacy tools are not supporting to those the big data types data because of the size, primarily because of the size, right? So, and also when we do that analysis to our computers, it's take, even though we started to do analysis from our tool, it takes some time and it needs some computational power and lot of things, right? So that's because of these reasons, let's say example, from the data domain, big data became to the picture, and people started talking about the big data because of this reason, because our old legacy tools or our old legacy methods are not workable for this big data, right? Okay. So that's the main reason why the big data word came into the picture, or people start that is the reason people start discussing about the big data, right? Okay, so let's move to the next slide. Maybe. Okay, so here is couple of example, right? In the New York finance market generates about 1 terabytes of trades per day, right? 1 terabytes of data per day, right? 1 terabytes of data per day, right? So now you can think about if we get a data set of 30 days, 30 days, this size become approximately 30 TB, right? 30 TB, right? You might think that this is not a huge size because probably your hard disk also have 1 TB, 2 TB. But the problem here is we are talking about a one single object, right? But in your computer, maybe you are storing some movies, some storing some like MP3s maybe, and you are storing your document. So, but here we are talking about the one single data set with the size of 30 TB, right? Which is very huge. Just think about you are having a movie, you are having a movie with the 30 TB size. Do you think that your legacy players can play this? I don't think. Because the players usually support maybe 4 GB, 5 GB, 6 GB. That's the usual size. Or maybe 12 GB, 15 GB, right? If it is go to the very high quality movie, right? Not more than that. But if you have a 30 GB movie, probably your players will not support, right? Okay. So now you can think, you can like get an idea about how big this big data, right? And let's see this one. See this one. So usually Snapchat creates around 2.1 million transactions, data generations per minute, right? Per minute. Then people use Google, and based on that, Google generates around 3.8 million data per minute, right? Per minute. This is per minute. Then Facebook generates around 1 to 2 million data per minute. 1 to 2 million, 1 to 2 million data per unit. Then YouTube, 4.5 million data per unit per minute. Then if you get all the emails what you are sending, maybe Gmail plus Yahoo plus all the email transactions, usually we do around 188 million per minute. This is the size we are talking about, right? See this one. A sing a single jet engine can generate 10 plus terabyte of data in just 30 minutes, right? 10 plus, let me close. Okay. So how can I close? Okay. 10 plus terabytes of data in just a 30 seconds, right? So, and this data is using for some checking of the health and prediction. So you might think about the why this is generating this data. The reason is to check the engine's health and fuel efficiency. But see the size, right? Then let's go one more example, which is related to your domain. In the healthcare, uh, this health electronic health records usually store the vast information across millions of patients. Let's say if in Sri Lanka, usually we use the pen and paper. That's also kind of a data how we are storing. But when it comes to the other countries, the most cases nowadays, eh, the people have started using some electronic ways to like record the patient data, which is the structured way. So if you get that kind of data, so around across 1 million patients, data is gathering uh, per minute in the healthcare center, right? In the healthcare process. And think about that the what do you call the smartwatches monitors lot of data like health rate, then glucose sensors, then oxygen sensors. It's a huge number of data, right? The same the thing when it's come to the Amazon and some other e-commerce sites generate the huge data to track their uh, browsing, right? To track their browser behaviors and all stuff. So the thing here is that so if a system or maybe website started generating a data, there should be a place to store those data. And also, there should be a way to get the data and extract the insight or the to able to analyze, right? So we will talk about the later slides how we are going to analyze this data, but just at the moment you have to think about the how big this big data, right? How large this big data, right? Okay. So here I have put a small slide in a tabular format to understand the sizes, right? Yeah, in the previous slides, we talk about some gigabytes, some terabytes, maybe zettabytes. So this is how the size distribution are going like. So our smaller part is the bit, right? Smaller part is the bit. Then we have another part nibble called 4 bits. Usually we are not using this bit and nibble. We probably start straight away from the bytes. Then we have the kilobyte, megabyte, and gigabyte. Probably we are not talking beyond the gigabyte, right? But big data always start from the terabyte side. So you can see that either the data size is maybe terabytes, petabytes, or exabyte, maybe zettabytes or yottabytes. So these are the byte sizes, and these are the number of bytes, a number of bytes in the corresponding name, right? So if it's zettabyte, you can see now how many bytes are included in here, and how many bytes. Then here you can see how many bytes are included here. Likewise, you can see the size of this part, right? Okay. So next. So when we talk about this big data, there should be a way to correctly classify which are our usual data and which are the big data, right? So So, so the data scientists, they define the big data calling a concept 5Vs, right? 5Vs, right? For these 5Vs, we have 5 characters, right? We have 5 characters. The first one, the volume, yes. A big means volume, always. If the volume is high, the big data, then we have the velocity, then we have the variety, then we have the veracity, then we have the value, right? There are 5 V's listed here. So let's go one by one how and why how they define these 5 ways, right? First thing is volume. As I said earlier, referring the amount of the data generated or the stored. Then the big data involves massive data sets, often in the terabytes or petabytes, which is the sizes. So I put some examples. Healthcare, then collecting millions of patients, as I said, MRI images. So the volume is the first V, right? Then let's go to the second V, right? The second V is the velocity, the speed at which data is generated, processed, and analyzed. So when we talk about the speed, the big data is generating very speedily compared to the legacy way. I mean the legacy data, right? So it is because the because of this exponential growth, the data is generating very quickly, right? Then real time or near real time processing is often required. So when it's come to this velocity, the character, so the big data needs some processing of the real time because it's always keep on generating, right? As an example, streaming data from wearable health monitors and ICU machines. So those are the examples for when we get as a character of the big data under velocity, right? Then the next one is the variety, right? The variety is the type of the data, right? There are a lot of type of. So even the big data, even the legacy data, we have a lot of type. The text, then images, then audios, videos, either sensor data. There are a lot of data types we are talking about. And also, we have main three structures or main three different types for the data. I will explain it later. Those are structured, semi-structured, and unstructured, right? Those are the three main different type of big data we can see in the big data, right? So here I have put examples, EHRs, then lab test results, X-rays, kind of doctor notes, then social media posts about health. So those are some example for variety. Then veracity. Veracity is refers to the quality or the correctness of the data, right? The big data may be incomplete, inconsistent, or the inaccurate, right? So it may have the duplicate data or the duplicate patient's record or the incorrect reading. So the big data might have these inaccurate data as well, right? So another character is the value. How useful those data to take the decision or gain the insight, right? So maybe the data might not give any insight, or it's give the very meaningful insight if we do the analyze, right? And as an example, some using the predictive analysis to improve the patient outcome. So if we collect the huge number of data from the patients, I mean the proper data and the correct data, it's useful to analyze or improve the patient's outcome, right? So that's the value of the data. And apart from those 5 ways, there are some ways you can consider when you think about the what do you call big data. Those are variability, then visualization, then vulnerability, then volatility. So those are the files you can usually use to define the big data, right? Okay. So the next is that the structure of the data, right? Or the type of the data, as I said in the previous slide. I think I explained it. Variety, yeah. So here the different type of data. So let's go. Let's learn about what type of digital data we are going to talk about. First thing is the structured data, right? Then we have unstructured data. Then we have semi-structured data, right? So when it comes to the structured data, these are very complete data, right? I mean, the data might have kind of a how to call the proper heading, and the data is well arranged. Then either we can extract the data points without any issue. So those have the kind of fixed format to locate the proper location of the data, right? We call this as structured data, right? And for some cases, we might need some computer pre-processing to get it structured. Maybe that's also we can call as structured data, because even though we put some effort to do the cleaning part, so once the cleaning is done, the data set, we can call this as a structured data because it's structured. It is structured, right? Then yeah, I put a small note here, like 10th 21 bytes equal to the 1 zettabyte, right? Or 1 billions of byte forms a zettabyte. Looking at this figure, one can easily understand why the name is big, right? So as I said, the when we talk about the zettabyte, if we convert it to the bytes, and if any data set is we are talking about the zettabyte, then you can think about this number of bytes included in the zettabyte. That means this is a huge data set, right? Okay. So here is one example for the structured data, right? So maybe these names, or some of you might heard about these, they structured, unstructured, and semi-structured, and those V's, but I'm re-highlighting those words because if anyone missed this part, those people should learn it. But otherwise, if I go straight away about the analyzing part, will not work, right? So these are basics which we should know when if you are a student of or learning about the machine learning or the AI related stuff, right? Okay. So structured data. So these are the structured data. So in a simple manner, though these structured data has a sort of what do you call a proper heading. Then it has a kind of proper columns. It's divided in a proper manner, right? It's divided in a proper manner. Okay. Give me a second. Okay. It's divided in a proper manner, right? So you can see the columns and the rows, right? Okay. Okay, so let's go to the unstructured data. So as if you read the name, then the opposite side of the structured data, opposite side of structured data we call as unstructured. So unstructured means that the data might not have proper pointing or proper heading, or not well structured, or maybe some data has structured but some data has not structured. So those kind of data set we can call as a unstructured data, right? A typical example of unstructured data is a heterogeneous data source containing a combination of simple text file images. Okay, example, if you get in a simple example, if you get in a Google search, if you searching any search keyword in the Google, it's generate kind of an unstructured data. Why I'm telling that? You are not actually inputting the structured input, right? Then the Google will search that string, and it's also generating the unstructured data, because it's not a kind of a structure, right? It's created some cases it gives the images, and in some cases it gives the text. So if you extract the entire output of the Google search or the search result, you cannot locate it in you cannot get it in a proper manner, because the output coming from the Google is unstructured, right? So for still some extent that you might be able to structure those data, but when you think about the entire data set, you cannot find it, or you cannot structure it properly, because there are no proper pointings for the features or the headings, right? Here's example, the same example what I said. The output written by the Google. So once you search, this give sort of this kind of an output, kind of a context, then it creates some sort of the suggestions, or maybe some cases some sort of images. So those are not structured, right? So if you are facing if you try to download and get store in a proper manner, you might feel that you will experience a lot of difficulties uh, uh, because of unstructured data, right? Okay. Then this is the main part, right? Semi-structured data, right? So semi-structured data can contain both forms of data, right? We can uh, this is a kind of a combination of structured and unstructured data, right? And semi-structured data as a structured in the format, but it's actually not defined with the example, right? So uh, the maybe it's a okay. So let's talk about this, like this, right? So this the most of the current models, we use semi-structured data, because the reason is you cannot find the data set or the big data completely structured manner, right? So for the most cases, we use the semi-structured data for the training purpose, right? Because think about this example, right? I will explain it how we create the XML and other JSON. I will create in the next slide, right? So if you get an example, if you wanted to extract the first name and last name from this name field, you may have a difficulty, because if you are going to extract the first name, you might not able to extract properly, because this is pointed the name for entire field, right? But if you want to extract the sex or maybe the age, it's pointed in a proper manner, right? Yeah. So the semi-structured data is till some extent you can extract the data, but till some extent you cannot extract the data because it needs some further adjustment of the data, right? So the next I put a small activity. I will do that activity to understand the XML and JSON, right? This is very important because the most of the text extraction versions, or maybe as an example, think about that. Think about if you wanted to, like, you have, maybe you might have some x-rays of maybe the hands, x-ray of the hand, and you wanted to like create a model to understand whether the main bone is broken or not. Think about that, right? So the process of this is that if you are planning to creating a model, the first process is the data collection, right? That is, we all know, without data, we cannot create. The second important process is that the data labeling. Data labeling, right? If you are not doing the data labeling properly, you cannot extract the features for your model training, right? Because model training depend on the features, right? If you are not giving the proper features properly, then you cannot get it. To give that feature to the model, you have to do the data labeling, right? Example, let's think about, there's an image. This is the image, right? So this is the hand. My drawings are not so good. Forget about that. Okay. So just think about, this is the place where the bone has broken, right? So to give this is as a broken, you at least you have to label to a bounding box to show to your model, this is the place you have to put the attention. You have to say to your model, right? And maybe if you get another picture, maybe the location is different. The location is different. Location may be in the upper part. So then you have to tell to your model, when you are training, this is the part to say. So my question is that how you can tell to this model or during the training, this is the location you have to refer. How do you going to tell that? So the thing is that this is where you need the proper data labeling, right? So when it's come to the image, think about in this scenario, either you have to give the let's say example, I will draw. So this is think that this is the y-axis and this is the x-axis, right? This is 0 0 and this is x and this is y, right? Think that I am placing my x-ray here, right? So this is my x-ray, right? This is my x-ray and this is the hand, right? Now think about, maybe, okay, this is the, okay, so this is the place where broken, this is the place. So I am drawing a small bounding box here synthetically, and I am extracting the details like this, right? I am telling to my model that my image size is this is the x coordinate, maybe 205 pixel. This is the place maybe, and here the place is 260, right? This is the size of the image, right? Then I'm telling that out of in this image, you can get this broken place. You can put a like this. If you remember your mathematics, simple x1 and y1, and here you can give the x2 and y2 to give you a model to find out the correct location. Maybe this is this point may be 102 pixel versus maybe 107 pixel, maybe this place I'm talking about. And this one you can give as a maybe 150 and 140 or something. I'm getting a synthetic here. So that once you give these points to your model, then model knows that this is the place you are referring. This is the place you are. Then it's extract the related pixel from the image to understand the difference, right? So now the thing is that you have learned the concept. Now the thing is, what is the format you are giving, right? So at that point, you can think about this XML or JSON, the formats. You should know, or you should have knowledge of this XML, JSON, or some other maybe CSV formats. CSV is kind of a very similar to the XML, but when it's come to the large data, we always go with JSON and XML because it's the XML and JSON are text type of formats, but CSV also a text type of format, but it's easy then the JSON and XML are very easy to handle, right? So when you give the data to your model, you have to know about this JSON and XML, right? So let me very quickly go to how you can implement a XML file for this data set, right? I will, okay, so okay, so I hope you can see my screen, this notepad I have open. So in notepad, I will open a meaningful text, right? So I believe that you might have some knowledge about the taggings. Taggings means like how can I tell that? So think that if you have a tag called A, you should have a tag called closing A tag, right? We call this as a pair. So whatever the thing you can insert here, you can extract while calling A tag. So A tag insert this value, right? This is the tagging in a simple term, right? Okay. So here, this is the structure. Think that how I am thinking, right? So this table has a person data, right? So I will put a name called person, right? Name called person here and person, right? So this is my so this is my tagging, right? So this is my tagging. I have a person's name table. Then, right? Then I have a first row like this, right? I have first row like this. The first row, I will put this as a row, right? To understand easily. Row closing. When you create your XML for your dataset, you can define these tags are not in the XML. Tags are not you can define whatever the tag, meaningful tags, right? Okay. So I have added one row. This is the first row what I'm going to insert here. In the row, I can see one ID, one column name called ID, right? In ID, you can see the value one, right? And also in the next one is age. age. In the age, you can see data point is 64, right? Age. Likewise, you can see gender, male. And here you can see gender, closing tag. And also we have one more thing is country. Within the country tag, you can see Sweden. Sweden. Okay. So this is my first row, right? This is my first row. And likewise, you can create your next row. This is kind of a second row. This is 50. Likewise, you can create your second row, and the same thing you can implement your all the rest of it. Now this called as the XML format, right? This is called as XML format. And other thing is that the JSON format, right? The JSON format is always start with these two curly brackets, right? These two curly brackets. And we have a lot of ways to, lot of structure we can do this. In the XML as you can put a row, and within the row you can call as a element 1, element 2, element 3. So JSON and XML, there is a structure pattern, but the keyword and key and values you can values should be similar to the data set, and keys you can define as you need it, right? So here what I'm going to do is, here you can do this. I will create, this is my row, right? Think about this is my row, right? So I will add here ID, sorry, ID as a 1. Then I have age as a 64. Then I have a gender. I will add that as a gender male. I will, since those are string, I will put the double quotes, and country 3. And the country is sort of Sweden. Sweden, right? So this is the format, right? This is the format what I have added, right? So the same way you can implement here, so that you can edit the same row number of rows. You can for the entire your data set, right? So the thing here is, that let me go to the site. Okay, so I will explain it. Okay, so I will put my the JSON here, right? And I will try to convert that to table, right? Here, see this. So now you can see that your JSON has this. If you turn it JSON to the table, you can see the same table what you have referred to build, right? So example, if you go to, okay, in case if you think about that, if you are deleting this something, some values, when it's create the table, it's give some errors because you have not followed the correct JSON structure, right? So the idea is that JSON has a structure, but you can change this value as you needed keys, right? So to this age, you can put any name, and And for the gender, you can put any name. But you should know that this you have pointed that data to the correct value. So usually we call this as a key and this as a value. This is the key, this is the value. This is the key, this is the value, right? So you can use any key, but the value should be same as your data set. Otherwise you are kind of generating the incorrect data. But you should know that uh, when you train your model, you can easily get your data if you use, especially when it's come to the big data, having the creating XML or JSON for your big data is very helpful when you extract the data. Okay, right. Let's move to okay. So now the big data, when it's come to the big data, the main problem we we wanted to tackle here is that the analytic part, right? So when we have the data, what we do is we do analytics part to understand the structure of the data. We draw some bar charts, we draw some pie chart, and we check the statistic of the data to understand or analyze the data. But when it's come to the big data, we also need to do the same thing. But the problem is that because of the size of the data, we cannot use our legacy tools or legacy pattern. I will show one example, right? So here, think that Excel, this is the Excel, right? This is the Excel format. So here, I will, okay. So here, this has example, let me show. This has only 16,383 rows, right? Sorry, columns here. Columns, I mean the X side, right? If you wanted, when it's come to the big data, you might have a lot of columns. So now the most of the data you are talking about not more than 50, 20 columns. But when it comes to the big data, maybe you need 100, 200, 300, 3K, 4K, 5K, maybe 30K, 40K rows for your to replicate your data, right? But this Excel, the limit is, as I said, 16,384, right? See this side. If you go to the number of rows, how many rows? This is about 10 million, right? Yes, 10 million. Maximum 10 million data you can store here. But we are talking about, we are not talking about the 10 million. We are talking about more than 10 million, right? Rows, right? So in the I think in the YouTube, it's generate around, I think 14.5 million data per minute. So it's not this storing the data in an Excel format is not even enough for a 5 minutes data to store the 5 minutes data, right? Okay. So because of these issues, right? Not about, I am not talking about only the Excel. I just compared with the Excel because everyone is know about the Excel. But all our legacy tools are not supporting this to even store this data, right? So because of these problems, the researchers has started doing some researches. So how we can do this, store this big data. So even we store this data, how we can extract this data and how we can get inside the data, they have started doing researches to understand or find out a way to handle or tackle this problem, right? So here are some problems they faced when they do some their analysis or then they do some research. The performance issues, right? To analyze such a large volume data, big data analytics is typically performed using the special softwares and tools, right? The when it's come to the performance, to handle this data, we need a softwares or applications which has the high performance, right? We should have high performance because the size of the data, right? So the legacy tools or legacy softwares cannot do this process because it's even though it's supported to store the data, due to some performance issues, it's keep on crashing the memory and keep on crashing the 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 processors when we do the analysis part, right? Okay. So and I will explain some of the software's later slides. So think about that. So even though we have some sort of the tools to handle the big data, the most of the organizations still having the challenges of handling the data, right? Still having the data, right? Because the difference of the data format, maybe it's as a structured and unstructured. Think about that. If you wanted to, let's say, if there is if when you when maybe think that if the YouTube is storing the all this keyword in a one row, right? Think about that scenario, and you are getting a 30 days data set to understand the what is the frequently used to find the frequently used keyword. Think about the scenario. In that case, if you wanted to extract uh, the number of search terms related to the healthcare is a huge issue because that particular part is not tagged in that the given search term, right? Because because of because the unstructured because of the data is not structured, right? So even though, as I said previously, even though we stored the data in a table or uh, in a in a platform where we can store the data, the we need we in many cases we need some pre-processing to get the proper output as proper output as we needed, right? Okay. Uh, uh, the when it's come and another thing, the second challenge is that so if extracting is fine, if you wanted to pull some data to this kind of an unstructured data is not possible. It's not easy actually, right? Because of you cannot find out the correct place or current point. Think about that. If you have an data in Excel format, if you wanted to replace any data, or you can do if you need to push some data, you can simply push, right? Or simply you can replace. Just search in the word. But if you see some unstructured data, you're having some trouble because you don't know which keyword you need to search, right? Okay. Those are some challenges. Uh, so I will skip this slide because I will later explain some with some analytics too. So here I have put one slide that benefits of the big data analysis, right? The same benefits you can get even though in the data size is small or even though the big size is huge, you can get the same benefits. But the thing here is that if the size is huge, or if you are, let's say, if you are predicting something, just getting an idea of the 100 records, accuracy might be lower. But if you are predicting something, or if you are taking some insight for your company, and by analyzing 1 terabyte of size of data, or maybe it's 1 zettabyte of data, will might be have the good accuracy when compared to the previous one, right? Because it covers lot of varieties, right? So the most of the companies, because of this, the most of the companies started doing their analysis part using this big data, and they have started collecting their data. They are collecting over and over the time, and the most of their softwares keep on collecting their data. So even as an example, if you have an e-commerce site or maybe the shopping site, so when you are searching anything, it's keep on recording you all the searches and all the ways all the activities you are following, right? And the people started that recording that thing, and it's storing uh, in a platform where the big data analytics is support, which I will explain it later. And then again, it takes some meaningful insight to uh, do prediction about the uh, upcoming or the changes of the company, right? Uh, okay. So that is the main idea of this slide, but I have put some sort of details in a descriptive manner to understand why analyzing big data is helpful for a company growth or boost their sales and increase the efficiencies and improve the operations, right? So all these stuff can be handled, boost sale, increase efficiencies, improve operations, improve the customer service and risk management. So all this stuff you can get an understanding if you analyze the big data, right? Okay. So here, these are some top big data applications, right? The application is sense, these are some areas where big data is generating, and because of that, the people started putting the application for those areas, right? Example, travel, then education, then telecom, right? Then e-commerce, then media entertainment, retail, finance, healthcare. The, the, the most of the domains, right? Most of the domains has they have put their big data applications to analyze, to store the big data, then do the analyzing part, right? So the same thing I have mentioned here, that the big data application, where the top list of big data applications who compare to this list. And now let's discuss some applications. Hold on. So some applications which we can use for big data analysis part, right? So there are three main applications nowadays people are using to analyze the data, right? One is the Cassandra, right? And other one is the Hadoop MapReduce. Other one is the Apache Spark, right? These are kind of a framework, and these has their own technologies. And apart from these three, there are a lot of we have a lot of framework, but these are the main three framework which has some their own features. And since these three are open source, the people started using their their technologies, right? Okay, so I will explain. Okay, so when it's come to the Hadoop, I will explain one what do you call, one framework. Then later I will do a small activity using another application, right? Here, okay. So Hadoop is a Hadoop framework provides the way to store the data and way to extract the data, right? It's create two ways, two things, right? In the Hadoop system, in the big data, as I said earlier, there are two main problems: how to store data, how to extract the data, right? Two things, right? How to store data, how to extract the data, right? So in the Hadoop system, to store data, it is using a way called Hadoop distributed file system to store data, right? How it is storing the data is that, let's example, if you have a 500 MB file or maybe 300 MB file, it's dividing for smaller chunk, right? It's dividing for a smaller chunk, right? And it's keep a index, example, it's keep an index file here, kind of. This is I have a 500 files and I have divided this into 3, and these 3 files I have placed these pieces or these server clouds, right? This is the index file, right? So we have index file. This index file refers how the files are chunked and what are the location it's saved, right? And also in the Hadoop system, for a safety purpose, it has, example, if I get a table like this, example, this is the first, think about that, this is the first point of the data set. Then it has a let's say, so if we have A, B, C servers, kind of an A, B, C servers, it tells that this part divided to smaller chunk, P1, part 1, part 2, and part 3. Then part 1 saved in P here. Then part 2 saved in P here. And part 3 saved in P here. And the same way, again it is recording. If it is, when it's placed the P3 here, it's placing P3 in the A server as well. And when placing the P2 here, it's placing P1 here as well. P1, right? P1. And here it's loading P2 as well. Now the thing is that, in case if the B server is crashed, the system still have the P1 and P2 in 2 other locations, right? P1 and P2 is in this there is a two locations, right? If in case this one is crashed, still have the P3 and P2, these can get in the two locations, right? So this system, this Hadoop system has, since because of this data is big, it's splitting to the smaller chunk and storing to the couple of location, as well as for a security purpose, it's creating a copies, multiple copies, maybe 2 or 3 or 5, that can be defined when server configure, is saved in a multiple copies in the defined same set of that's how the Hadoop distributed file system store in the data, right? That is the way storing, right? And let me this okay. Then Hadoop, when it's come to the processing, I said that two things for when it's come to the data, big data. One is the storing problem that's solved from the previous one. The key point is when it's store, it's split into the smaller chunk with the index, as well as for a safety purpose, it is keeping the couple of copies as well. And when it's come to the processing, it's processed a splitted manner, right? Example, if the process is if we given a task called A, it's splitted the same task into a three different uh, queues, right? Then it's allocated to different queues to do the same process or the part of the process. Then it gets the output, right? We call this as a map reduce, right? It's go to the mapping process. It's mapped to those chunks. Then the previous, as I said in the previous one, is there's a map in the process. Then it's split to the smaller chunk. Then it will process, right? It helps to reduce the time of the processing, because uh, if you are processing or if you are extracting or analyzing the data from one single maybe or the PC or single instance using your legacy method, it's always runs one task. But when it's come to the Hadoop method or the Hadoop technology, it's splitted to the smaller chunk when save the files, and as well as when it's process the task also treated to the different manner, different ways to process, and then it gets the result to the main computer. Then it's populate the data. This helps to reduce the speed of the uh, uh, latency of or the processing time, right? That's how the Hadoop is working, right? So yeah. Uh, okay, so we have another maybe another 40 minutes or something. So today we don't have the Mahisha's lecture, so I will cover that part as well. Uh, so let's go to the small activity, right? Activity. Mm, sorry, give me a second. Okay. 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 So, okay, let me show my screen again. Okay. So, first thing is that, okay, so before I do this, what do you call this practical session, I will show you a couple of places. Let's say as an example, couple of places where you can get data set, right? Where you can data set, right? Okay. So the first place is the Kaggle. This is the most famous website which you can use to get freely available data. I will explain, I will show you. Okay, so if you go to this site, if you can create a simple login, just clicking to sign up using your Google. I am not going to show that. You can simply create a login. And then you can see, if you click the data set, you can see n number of data set listed in here, right? N number of data set, right? There are a lot of data set, right? The cool thing in this site is that if you go to if you are actually learning the machine learning and kind of the AI related stuff, if you go to this competition, you have a lot of competition to what do you call it, join, right? You can and also if your model is giving the right accuracy, what they define, you can get some prizes as well, right? So as an example, I will show you. OpenAI Research Challenge. This is okay. So we challenge you to bring the legends to life in okay. Okay. So this is kind of an the helping LLM models to fine tune their stuff, right? They have given the data set. They have given the data set. So you can click simply the join this competition. Then you can keep on doing experiment. And also the best thing is that you don't want to go use your personal computer. This has a coding, the different coding library. I mean the different coding notebook. Once you clicked here, you can see this is the coding window or the machine learning window. So you can this supports Python, obviously, and you can this has a other thing. This has a some good CPUs and GPUs to run the stuff. So you can here itself you can import all of your data set and all of your what do you call the learnings here to get generated your code, right? So that's a one special thing of this site. And I recommend if you have a time. I'm not sure. I know that you everyone are super busy, but if you have a time, so just go and see the competition. The other thing you can see is that once you go to the competition, you can get an idea what type of models people are thinking to create, or you can get an idea what is the future of this AI, right? Okay, so as an example, you see this detect behavior with the sensor data, right? So this is something new, right? Today morning when I prepare this session, I simply just click here and check that this is something new for me, right? This is the some of company is trying to create the behaviors of the electronic component based on their temperature, proximity, and the movement. based on those, it's trying to create the behavior of that component, right? Very cool things, right? So likewise, if you go and see some data set name, even though you have not participated, to go and see the data set, then you can get some better understanding. Here, this is a very simple thing, I guess. Image matching challenge, right? The thing here is that I guess that you have to compare two images with the similarities of the images with the what are the similarities of this. This is another cool competition. You can, if you have a time, you can participate, right? Okay. Okay. So if you wanted to get some data set here, you can go. So you can simply click the data set section and you can search here some data sets. So, okay, example, I will find this trending search food. Let's see. So there are a lot of data sets. So Indian food data sets. So once you clicked here, you can see, you can find here about the data set, right? Once you clicked, okay, you can see the data set and what sort of features they are, the name, ingredients, then diet, preparing time, cooking time, flavor profile. Likewise, the data set name and the features prior to download or prior to use, you can see from here, right? You can see from here, right? And also in the coding section, in the coding, you can see the people who log to this Kaggle site, the items or the analyzed part or maybe some sort of the model preparations code they have made for this data set, right? So as an example, I will filter is the most total. Okay. So this person has done Indian Cushing analysis. Let's go. Let's see this. Okay. So he did some analysis using the data set, using this data set. So see the analysis, how what that person did was try to analyze the data structure and with how many vegetarian and non-vegetarians and what are the dishes based on the range. Likewise, you can go and see the analysis they have done. This is the analysis part, right? Or we call this as a EDA. So when it comes to data sciences, or if you are planning to do some machine learning models, so if you are learning about machine learning, the first thing is after done the data collection and the data annotation part, the next step is the EDA part, exploratory data analysis part, right? So you have to do the data analysis to understand about your data, right? You cannot get an understand without this analysis part, just looking at the data or the structure to get an understand whether it is helpful, whether the data is useful for a model training. If you did not done the analysis part properly, you will fail for sure, right? Because this is the key component. Data analysis is a key component if you are creating any model training, right? So to to fine tune your knowledge, data analysis knowledge, you can go to this. You usually do that data analysis part because when you treat some person, you check the what you call the historical data and get some idea about that. What is the maybe the previous medicine that patient has taken, then what are the symptoms or whether kind of sort of data you're analyzing, right? But the same way, in a different manner, you can do the analysis part for the data sets as well. That's give some better understanding of your data set, right? So those things also you can learn from this side, right? Okay. Let me. Okay. So once you find a data set to use in your for your project, you can simply do this thing, right? I will go to one data set. Hold on. Cancer. See, just I remember this data set. It's a cancer prediction. Okay, so okay. Okay, so I will take this data set as an example. So I'm going to use this data set for my analysis purpose, right? Okay, so what I'm going to do first thing is, if you are going to use this data set in your different maybe Colab book or maybe different platform, you have to first download your you have to go to your settings and you have to first download the authentication key, right? There's a token, right? As an example, I will create a one token, right? Once I clicked it, how I go to this option, settings, my profile, settings. Within the settings, you can go to the create token. And once you click here, you can see your, since I have already downloaded that key, it's renamed as _1, but you can see this kind of an kaggle.json file, if you are downloading very first time, right? So I will download here. That key has, see this is also JSON format, as I said, as I explained in the previous, right? This also you can see a key, my name and my key, right? Okay, so what I'm going to do is, first I will go to my Colab book and I'm going to install that that file, right? You have two options to do that. One is you can simply drag and drop to your Colab book, right? Then it will start loading, right? You can simply drag and drop here. Or you can use simple Google Colab upload function to locate this file, right? Example, I will delete here this, right? I will run this part. Then I will choose my file. This is where I place my file. Then I will upload. So the file is automatically placing here, right? So the file has been placed here, right? Then I import this file to my file upload permission path, so that when I download any files, it's refer these keys to when I do the downloading parts, right? Okay. So I have moved that part to one of location called root, which is inside the Colab book. That's why it's moved to that location. Then I download my selected dataset. This is the selected dataset, the cancer dataset, what I am going to download. So this name I got from here, right? As an example, let me show you. I will copy this name and I will go to dataset / if I put my name here, you can see the dataset. So the same way how you can give it, you can go to your dataset. If the eye cancer patient record, then you can copy the last part and this part, right? You can just simply copy and you can simply place here to download. Then your data set will automatically download when you run the command, right? So Kaggle dataset download, then I will download my dataset, right? So the dataset is downloading, right? Okay. And it's extracted here, right? It's extracted here. So this is my dataset, right? Now I will first do before I go to that big data part, big data analysis part, I will show you that dataset here, right? I have downloaded that to my PC as well. Where's the dataset? Okay. This has 91 MB, right? This has 91 MB. I will close over this stuff. 91 MB. Okay, so this has 91 MB. So I will double click here, this to open in CSV. Okay. So it took some time to open. The reason is that I will show the reason actually, right? So I will show the reason. So if you look at this data set, this has 8 8 lakhs and 90,000 record, right? 8 lakh and 90,000 record, right? What I said is this has a 10 million. Out of 10 million, this dataset cover around 8 lakh of dataset, right? So this is kind of high, but not like a big data. But I took this to explain some sort of thing, right? Okay. So in this using this Excel, right? Using this Excel, which is our legacy method, right? I'm just trying to do some sort of things, right? Example, first thing, I will with age here, right? When you click here, you can see that the filtering take some small time, right? Right. This is I'm talking about this just for a 8 lakh of record, right? And gender also taking, even though there are two values here, but it needs some processing to get to check whether the number of results. So likewise, for some cases, it take a lot of time, right? So when it's come to this legacy way, the even the handling, uh, even we do a very simple thing, it takes some time when it's come to the big data, right? This is not a big data. I'm telling again and again, this is not a good example for big data. But since I'm using one simple computer, so I took this as a example, right? So first, I will try to get using our legacy. So this is Pandas is a kind of a framework where we can do the simple data analysis part, right? Data analysis part. So I use these Pandas data frames to do some sort of analysis part to understand the data sizes and all, right? So I will first take don't think about that if you don't have an understanding about the coding part, I can understand you should in your domain, it is not needed. But if you are not familiar with this code, just don't think about the way, but just listen what I'm telling, right? Now, So what I'm going to do is, out of these 8 lakh, I'm just trying to get the what do you call, first set of record, uh, the header part of the data set, right? This is usually how the data scientist is doing. The data scientists are usually first extract a couple of records. Maybe I will define here as a 10 record. First 10 record I'm going to check here how it is appearing in the column. So here how the data is appearing, right? Right. When I run those things, you can see that the loading is loading might taking some time because of the data size. Okay. And I will do this the this data analysis part using a legacy method. Then after that, I will do the using the PySpark, uh, which is the big data handling framework, right? So after that, okay, so after that, I will get the dataset information, right? And if you are a data analyzer, so in the pandas provide a lot of small function to get extract quickly about your data set. So example, if you get an data information from the panda, you can see this is ID column is pure integer call values. In this age column, the floating values, the gender as an object or string, the country, then it's gives some value. So as an example, in case if you see this age, the float and the int is a both are integer type. The float means that it has some this kind of a decimal values, 0.1, 0.2 something. But think that if age came as an object values, that means you should know that out of this 8 lakh data, there are some places where it's turned into a string values instead of some numbers, right? So then you have to correct it. So the idea of this getting some information to understand whether entire data set is in a same way, in the similar way or the proper way, right? Okay. And okay, so likewise you can extract the data points to understand information. And here from the legacy method, I extract some statistic and standard deviation, mean, then frequencies. So if you are doing that in Excel, simple Excel, you have to do a lot of calculation to get it done. But within a simple, in a simple, what do you call? In a simple command, you can get all those details, right? The what do you call, the count, how many data is there, whether you can see the unique lines or not, and like mean of the data set, then standard deviation, then the example, see this, the gender, there are two unique cells, yes, the male and female. So maybe if you see this number of unique count is 4 or 5, then you have to go and check what are the errors, right? What are the errors you can. So here there are 27 unique values, right? So if you conducted collecting the data set for 27 countries, then the number should be 27, right? If it came as a 28, 29, maybe 30, 35, then you should know you somewhere the data collection team has made a mistake, right? So this is the purpose of this analysis, right? First to understand some missing data, and then to understand some statistic and stat how the data distributed likewise, right? So okay, so I will go little by little below. Then I'm checking the missing data, right? Whether any of column has missed any data, right? So here this says 0. That means no any missing data, right? No missing data. If you think that if you are going to check at least one by one or using the Excel, how long it take, right? So this is very simple, right? Okay. And I will do small data point change in here. That is due to change the data format, right? Data format to understand the properly. Okay. So now now what I'm going to do is I'm still in the legacy way, right? To understand, uh, I'm going to create some sort of table and graph to understand the ways or the patterns of the tool, right? The in the data set, right? So here I have created one graph to understand the data set, what number of data set in the survive, and uh, number of number of records which fall under did not survive, right? And around in the dataset distribution is like 77% people survived and 22%, so 22% survived and 77% did not survive, right? And the same way, what I'm going to do is I'm going to create some male female chart and also the country wise survive versus unsurvived to understand, and family history. Likewise, I have created some charts to understand the sort of stuff, and also is the one of mm, the point, right? The next I have created a small chart to understand. Uh, again, the reason why I am explaining this sort of stuff to you to understand what is data analysis, right? So you can get a data analysis part as well as how to analyze the big data, right? So the two things you can cover from this, right? So here I have explained the correlation heat map to understand the correlation. These are very important, right? So even in your field, the correlation between. So you always you refer the correlations, right? So like you asking some how this happened, whether your family members have this disease. Likewise, you are asking some correlations, right? So same thing here. So I created a map to understand the correlation, right? So like as an example, always the diagonal is coming as a one because to age is or always correlated. One is the correlation is 100%. The zero is the no correlation, right? Okay. So when it's come to the see this cholesterol level and BMI, say there is a correlation, right? I don't know. Like you can think about. So when whether the BMI and the cholesterol, this whether it has a relationship or not, right? Maybe you can comment whether it's a correct or not. But when I try to get it, I see there's a correlation right here. Uh, and yeah, so this is until this time I showed the legacy way. I used using the simple analysis using the legacy ways, some other stuff. Now what I'm going to do is I'm going to use the PySpark to do the same thing, right? But when I do this thing, you might think that this is the same process in time and same ways happening, right? Here is the thing. The reason I will tell this is the reason, right? I will go to paint, right? So this is the reason. I can see there are three messages. I will reply to that at the end of the session. So this is the legacy method. This is the big data framework, right? So the legacy method are very straightforward and only process task A, task task A and complete the task A with it's a one-to-one direction, right? And it's easy. And when we have the very smaller set of data, not kind of a terabyte, gigabyte, then it's processed easily. But when it's come to the big data, if we have a task A to be done, it's divided to the couple of tasks. Then it will point to the data set to be done. Then the return the output to the corresponding the divided task, then it's coming to here, right? So if we use a same data set to the experiment, let's say example, I use here around 800K set size of data set, right? I'm going to use, right? This one and this one, this method, probably this method supports very quickly than this method, because 800K is not a big data, because it is, even when you compare it to your data, it's a big, but it is not a kind of a terabyte, gigabyte size of data. It's kind of an 91 MB, right? Because this is very straightforward, right? But this is not straightforward. This use a lot of units to get. But if you use 30 TB size of data to be processed in this way and this way, then you can find a clear difference. The legacy way take a lot of time to do the process. Maybe it will not give any response, but the new method or the big data processing methods give the proper output compared to the legacy method, right? Okay, so but as an example, I'm showing this how we can process it, but this is not the correct way to compare, right? Okay, so here first I will install the PySpark. Since I have already installed, then I will install the other rest of SQL libraries. And I will then load the same data set here, right? Previously, I used the pandas, which is the old way. Here, I will loading this to the Spark, PySpark data set, which the data framework which defined for the data, defined for the, what do you call, this big data analysis, right? The same thing we can do, the previous same sort of analysis I'm doing here as well. This is not to show the speed, but to show the things what we can get it in the PySpark or the big data analysis framework, right? Okay. Here, what I'm going to I going to like get the schema as in the previous one. ID is an integer, age is a double, the same thing. In the different way, you can get it from here as well. Then first couple of data here, you can see the first couple of data. Then I will try to get some count here. You can see that this takes some time. See, processing it takes some time compared to the previous one. Yes, that is correct. But when we insert the big data, the legacy method will not support or will not give the output, but PySpark or the new framework will always give the result, right? Then I will group some data here. Then the same kind of analysis, right? Same kind of analysis in a different manner. Then I will map the groups to some sort of level. Then I will try to get some filtering here. Okay. So likewise, you can create a graph and you can do anything from the PySpark as well, right? The only thing is PySpark speedily support for the big data, not for the legacy pattern of data. But our legacy method like pandas or whatever the way is are not supporting quickly for the big data type of work, right? Okay. Okay, so that's all for today lecture. Let's go to some questions. Okay, so there are a lot of questions. Okay. Is ChatGPT also processing the data similar to the Hadoop? Yes, because uh, one thing, right? So Hadoop is not a uh, not a not a tool or framework to train the data. Hadoop is a platform or the framework which you can analyze and get the insight of the big data, right? So this is kind of a tool which you can display the data and analyze the data and extract the data inside, right? So and when you treat the whatever the language, whatever the LLM models, maybe the GPT or maybe the what do you call DeepSeek or whatever language. So first thing is that once they have labeled any data or once they have extract any data, they will use some big data framework, either Hadoop or either Spicebuck or either their own method, own framework to get it, extract the data, right? Okay. If we add the big data for the analysis purpose for AI tool, there is a risk of losing the privacy of such as data, especially patient-related data. Okay, so here is the point, right? If you are using millions of data to process of your patient's data, I strongly recommend not to use any sort of free versions, right? So the best thing is that this is the best way, right? The best thing is that create a account in the Amazon that is free for 12 months for testing purposes. And in that platform, you can get a instance created called Hadoop, right? I will maybe explain it later. Yeah. Then you can, in that site, in that system, you can install or you can put your own data. They have an agreement, Amazon have an agreement that they have not share any data to anywhere, right? Any data to anywhere. If in case leaked, we can file a case against the AWS, right? They have strict policies, even the Google. So the best thing is that Google also provides the same service. Best thing is that create an Amazon service account, and it's also create the lot of machine learning toolkits. Probably we can do one session as we discussed in the previous at least one workshop, how we can practically use the stuff. You can use that kind of platform, so then it will not push any of your patient data to the outside of the world, right? They will guarantee their data security, right? Okay. Are those data true values or just created a training purpose? This is regarding the data set, right, Dr. Dominder? The data set what I used for
Yes, yes,
this.
what you have shown. Yeah.
Okay, so those actually those data are for most cases true data. Those are actually extracted from some of the patients, right? But the thing is, there are two changes they are doing when the people are putting their data set for the system. One is they will completely remove all the personal details and replace with some IDs or maybe numbers. And the second thing, while keeping the same relation, they will alter the data. As an example, uh, if if the BMI is something like 35.5, then probably they will change it to 35.45, right? To show that data is not exactly the same as the patient, right? But you can still use consider that data set as a kind of the true data set, right? And also the other thing is, before you use the data set, go to the author's note, right? So this iCancer thing, let's see. Maybe the author, there is an author note, right? Author is saying that usually for this Kaggle, usually people are not uploading any synthetically created data. If it is uploading, they will always indicate that as this is a synthetically created data. So this is the owner. So MIT license. So usually if you see some kind of a license for MIT license, probably you can those data probably you can use anywhere, right? Anywhere, and those are altered but still keep the same structure and the same relationship, right? Okay, in a simple term, yes, 90% the data is correct, right? Okay, anyway, people can cheat to the system, ne? So anyway, in the most cases, data are correct, right? Okay. Then when using the data load dot, what is the data cutoff for big data? Or can we use to analyze about 100 participant data with the okay? So here, in the collab books, provide you can use until you can analyze even the big data, right? There is no cutoff. The only thing is that if you are going to analyze the big data, your server performance getting if you are using the free version, then it is getting it's give some latency when you are processing the data. But if you are just talking about the 100 data of the 10 parameters, I am sure that you will not get even a millisecond latency, because this is very small for Google, right? This is very small for Google, right? So you seen that I have loaded around 800k data, 800k data, 8 lakh data with the how many parameters here? How many parameters? 17 parameters. So it's worked well, right? It's worked well. It did not give any problem, right? So I believe if you are talking about the 100 200, it will give the proper way. But if you are loading around 1 TB 2 TB level of the data, then you have to first purchase. I will show that point as well. Okay, so here you have, here is the key, right? You have a change runtime, right? Go to this change runtime. Then the CPU is the way they are providing for the free users, right? This is always free. And based on the, based on the requirements, you can use the T4 as well. That is also free. I'm using I'm using the free version. I still can select this, right? I can, if I click OK, it's automatically changing, right? I will say, see that it will automatically change to the connected to the TPU. That is speed very faster than the CPU, right? Right. So see now, okay. And also still you can do the TPU, but you cannot use these GPUs, right? Because I'm using, I cannot use because I am using the free version, right? If you are planning to use 30 GB, 100 GB data, just go with this TPU and check it, right? But I strongly recommend that if you are going to do with some 30 GB, 100 GB data, don't use this collab book. Better you can use the Google other services. The Google Cloud services or the AWS Cloud services do this. Those as provide the same thing. But if anyone is actually, this is a nice question. But if you are interested about using the data, big data, but the only thing is the big data we are talking about a lot of maybe the GBs, TBs data, right? But the 100, 200, 400, 1K, there is no issue using of the what do you call the collab, right? Okay. The last question. ChatGPT is it good enough to reliable to the handle the big data? If not, is there a cutoff size? Okay. So ChatGPT. Okay, so if you are trying to do some analysis for your big data using ChatGPT, the ChatGPT will not support for that, right? The reason what I'm telling, it has a limit, kind of a token limit. If you go to the ChatGPT API, ChatGPT API, ChatGPT API services, probably you can see the number of tokens. Number of tokens they are allowing. Maybe that's okay. ChatGPT API. I remember I have created account somewhere. Sure. Okay, so I have not created yet again. Okay, maybe start building app. So this is okay. So this is in this. I remember in the pricing section. Maybe somewhere I saw that number of maximum token you can pass for a one request, right? The thing is that if you are using the GPT for your data analysis purpose, either you have to change, either you have to send and check your single line to for each single line you have to send to the GPT to get the answers, right? But it's not something like analyzing the whole data, right? So I am not recommending, and no one will recommend ChatGPT or any other tools to do the big data analysis. Big data is means big, right? It's a kind of an huge data, but don't think that the data what you have collected maybe 100K, 200K is a big data. That is not a big actually, right? That's not a big. We are talking about the TBs, petabytes, zettabytes sort of a data. So probably in your systems, right? In your system, so maybe if you extracted your maybe your systems data, you might find n number of the data with the TB terabyte petabyte size of data, right? If you extracted your sensors data from your sensors and some of data from your maybe your scans, so you might find out that much of data. But if you wanted to analyze that kind of data, you can put it to the AWS cloud services that will give the proper services to do that. So GPT is not recommended for that sort of data, but for the small things you can use for GPT. Great. One more question. Thank you so much. Okay, thanks. Great. I guess I have covered a lot of things about the big data. I believe this is my idea, right? So this is the minimum thing what I am expecting from from all of you, right? Maybe you might not able to get the entire session idea of this entire session, but if you learn about some of the keyword like big data, then Hadoop, then PySpark, then structured, unstructured, and maybe 5Es. If you are when you are talking with some people about the machine learning, if you are know about those stuff, that is the at least minimum requirement or minimum thing what I am thinking you should know about the machine learning, right? Then at least maybe you are not going to use the machine learning stuff in your domain. But if you are knowing that point, it's helpful you to like talk about or the understand some sort of the discussion which is happening in the machine learning side. Uh, Great. That's all for today lecture. I guess everyone got some good idea about the data, big data. So yeah, then let's meet then next week for with some another interesting topic. So until such time, have a nice weekend and have a nice week. Good night,
Thank
everyone.
you. Thank you. Thank you very much.
Okay, thank you. Bye bye.
Bye.